categories that the base core proxy type participates in, depending on how you define your objects, your identities, and your composition in each category. So I won't go too depth into what these types mean, but these are the 5 categories: push, pull, request, respond, collectively. And the advantage to having this categorical formulation is that there are certain rewrite rules that he can depend on, that he can know by proof will be correct in all scenarios. So he has pen and paper proofs of these in a GitHub repository, and that's been out there for quite some time. And it always was on my mind that wouldn't it be nice to formally verify this, because we've got, formal theorem provers. So I decided to take his, on the top is his code from his library, his core proxy type, and to represent this type into Coq. And the difficulty, you may notice this already, is that the top is not strictly positive, because this is a free monadic construction hiding in a custom data structure. So if you just take the top and encode it directly, it will not pass. The type checker will not accept it. So it took me quite a while actually to find out that if I hit this with the Yoneda lemma, because that solves pretty much all problems, then it becomes representable. Coq will accept it. It says, sure, fine, that's great. So I have this representation now on the bottom that is so close to the top that in my re-implementation of pipes in Coq, I just took the Haskell code, I copied it into the Coq file, I changed the syntax to be Galena. The only things I had to do any thinking about were anything dealing with the M constructor. And the conversions were almost completely mechanical in all cases. So it did not take very long once this trick was discovered. So now I can go into a file where I have one of these categories represented. So there's my respond category with my objects and my morphisms in the category, my identity and my composition. And I can say, Coq, process this definition for me. I don't know if the blue is going to show up. Oh, it doesn't show up. That blue is so lovely a color. Anyway, so here we have the right identity law. And you didn't see it, but it's telling me now that I only have 2 obligations left. I have to prove left identity. I have to prove associativity. And now I know I have a category for respond. And I'm sure you all trust me because you trust Coq. But we have all 5 categories proven, and many other laws besides that Gabriel has mentioned. So for example, he has a law that 4 within 4 is just the same as pulling this operator out, and that gives him in GHC an ability to optimize the pipes code. And so I can ask Coq, is this valid? And Coq will say, yes, that is completely valid. So there is a GitHub repository for this called Coq Pipes. If you search for that, you'll see that we have 43 laws proven, and every one of these has a link to the proof text for the law, and that is everything. Simon asked if I found any bugs while doing this. No, actually, I did find out that all of Gabriel's pen and paper proofs were correct. And when I was having some sticky problems with some of the Coq proofs, I just referred to his paper proofs, and that was the trick that I needed to get through. So, good job, Gabriel.
So this is about some programming with dynamic.